Howdy folks, so this is just a short little video talking about the way the body is going to emphasize one energy system over another depending on the intensity of the effort you're doing. Now, the amounts here are by no means 100% perfect and set in stone. Instead, this is a way that you can kind of visualize it. So when we talk about each of these durations, so from the 6 seconds, 30 seconds, 60 seconds, 120, 1 hour, 4 hours, and the idea of 4 days without stopping, which just sounds really metal and horrible. We're going to be talking about that's the maximal effort we can maintain for that entire period of time. So if you're going at 100% effort for 6 seconds, you're going to find all or the vast majority of your energy production is coming from your ATP and your phosphocreatine, your PC. So the shortest energy system. You're getting a little bit of contribution from anaerobic glycolysis, and there's always going to be just a little bit of background aerobic glycolysis, beta oxidation, and then deamination. Now, if you're looking at individual fibers, that's where you're going to find probably more of the pure aspect, but none of this runs in a vacuum. They're always going to be contributing from one to another. So we're talking about a maximal 30 seconds sprint. This is a Wingate bike test. This could be just trying to cover as much distance as you can through sprinting. You're going to be getting the vast majority of this energy production from anaerobic glycolysis. Now we're getting a lot more contribution, thank you, from aerobic glycolysis along with that ATP PCR. Is still useful, but it's not going to last as long. Now when we go to 60 seconds, notice how the ATP PCR just kind of disappears. We're getting still most of our energy from anaerobic glycolysis, more from aerobic glycolysis, and still very little from beta oxidation and deamination. When we're talking about 2 minutes, the 120 seconds max effort, now we're getting most of our energy from aerobic glycolysis. When we're going maximal for 1 hour, so this is going to be people that are really flying doing a marathon, it's going to be mostly through aerobic glycolysis. There's still going to be some anaerobic glycolysis, and there's going to be some beta oxidation, but probably more of the beta oxidation. Then when we go to something like the marathon, now we're getting a relatively even split between aerobic glycolysis and beta oxidation. Notice this is someone that's doing it for 4 hours, so this is not a super high-level athlete. This is someone that's at least being successful. And then if we're just, I don't know, trying to live our own version of The Long Walk by Bachman, which is this pen name of Stephen King. It's a fun book, very dark if you're bored, where you're going to be mostly fueling this through beta oxidation, so does fat metabolism. You're definitely going to be using glycolysis aerobically, and you're going to be using deamination, so breaking down protein for a fuel. Now, once again, none of this is in a bubble. Just the pie slices get to be so thin that you can't even see that ATP, PCR, and anaerobic glycolysis. The other thing to keep in mind when we're looking at this is saying that you're just going to maintain the same output for the entire time, which is not going to happen. If you're doing a sport, there's going to be parts where you're going to be just hard in that ATP PCR because that's at maximal sprint, and then there are going to be parts where you're going to be doing a walking recovery, which is going to be mostly beta oxidation and some aerobic glycolysis, depending on meals, training history, and everything else. But keep in mind, you're never just using one energy system. You're emphasizing one energy system more so than another, but you're never only just using one. The body's utilizing a variety of fuels in a variety of ways. And that's going to, once again, our intensity and the duration that we hold that intensity is going to give us which system we're focusing on the most. Thanks for listening. Have a great day.